Hi guys, welcome to me. How have you guys been? Yeah, so today we are going to discuss atomic structure. Okay, so this atomic structures history, we read about what are the basic concepts of chemistry, we discussed about moles, number of molecules, Avogadro law, different kinds of laws, isn't it? So in this atomic structure, the first thing on how atoms actually, what is matter composed of. So that was first given by Democritus. It was given by Democritus. So what he said was that this atoms are the one which are small indivisible particles which are present in the matter. Now later Aristotle and other people, they came to the conclusion that, yeah, even Aristotle, they came to the conclusion that the matter is composed of different kinds of elements such as fire, earth, air and water. So this philosophy which was, or the theory which was put forth by this Democritus was just pushed away. Okay, and then in 1808, a school teacher, okay, he was an English scientist who was a school teacher named John Dalton. Okay, so he formulated the division saying that the matter is composed of atoms, and we have discussed already what is the atomic theory, Dalton's atomic theory, that the atoms are composed of small indivisible particles, and in atoms, in compound, the atoms exist in always a definite ratio, and in case of a reaction the atoms will be exchanged, the atoms will be rearranged, but no atom is like changed into another. So we saw all of these properties and what are the demerits of it, merits of it in our basic concepts of chemistry, isn't it? So in this chapter what we are going to look at is what is electron, proton and neutron, what are the different kinds of species, what is the atomic model, how does atom actually exist. So we are going to talk about all that in this chapter. First, so this atom, okay, so the radii of the atom is generally given in 10 to the power of minus 8 centimeters, or it is given in 1 angstrom. And the radii of the nuclei, okay, the radii of the nuclei. So atomic radii is around 1 angstroms. Radii of the nuclei is around 10 to the power of minus 18 centimeters. Look at the difference. This is 10 to the power of minus 8, this is 10 to the power of minus 13. So that means radius of the nucleus is about 1 over 10 fifth, 10 to the power of fifth to that of the radius of the atom. Okay. So this is how, what is the difference between the atom and the nuclei. Now coming to electrons. Okay, coming to electrons in the structure of atom, the first thing which we are going to see is how the electrons were discovered. We are going to look at the discovery of electrons, protons and neutrons. So the first one is electron. So there was a scientist known as Julius Plancks. So he started the study with conduction of electricity. So the electricity was conducted through the gases at a very low pressure. So he was Julius Plancks, who is a scientist. He started studying the conduction of electricity through the gases at a very low pressure in a discharge tube. So now when high voltage, when high voltage of about greater than 10,000 volts, 10,000 volts was passed through, and at a very low pressure at about 10 to the power of minus 4 atmospheres, what happened was, he observed that there are some invisible rays which pass from negative electrode to positive electrode. So since the negative electrode is referred as cathode, we call them as cathode rays because the rays move towards the cathode. These rays are called as cathode rays. So the pressure which was maintained was 10 to the power of minus 4 atmosphere, and the voltage is about 10,000 volts. All right. So when these pass, there were some invisible rays which pass through, which are called as cathode rays. Now, what were the properties of these cathode rays? So they observed that they travel in straight lines from cathode with a very high velocity at the range of 10 to the power of 7 to 10 to the power of 9. So make sure you pay attention to the properties of cathode rays. You might get a statement saying which of the following is a property of cathode ray, not a property of cathode ray. So even questions like these can come in your exam. Okay, so make sure you pay good attention to what are the properties. So he observed that they always travel in straight lines and a shadow of metallic objects. So if I place a metallic object in the path of the cathode rays, always the shadow will be placed. So what does that mean? These rays, they have some light intensity, isn't it? Now, the third property is they produce a green glow when they stick, where there is a zinc sulfide screen, they can produce a green glow. So that means the light which is emitted is green in color when they hit the zinc sulfide screen. So that is the third property. What is the screen used? Zinc sulfide. The next property is that suppose if we place a small pinwheel here in the direction of the cathode rays, isn't it? So if there is a small pinwheel where the cathode rays emerge, right? So this pinwheel, when placed in a path, these blades are set to motion when the cathode rays move. So what does that mean? That means these cathode rays have some amount of mass and velocity that is able to move this pinwheel, isn't it? It is able to move it. It is able to rotate these birds. That means it has some amount of mass and velocity. So the other thing which was observed that these cathode rays, they can be deflected when placed under electric and magnetic fields. These rays can be deflected when placed under electric and magnetic fields. So if I place some two electrically charged plates, right? If I have two charged plates, always they deflect towards the, if I have a positive and negative plate, they will deflect towards a positive plate. Why do they deflect towards the positive plate? Because they have a negative charge. So this plucker, this J.J. Thomson, he called them as negatrons. What did he call as? Negatrons. So Plucker, James Plucker was the first scientist who actually observed these rays. Okay, and Thomson, he observed that when they were placed under electric field, they were deflected towards the positive electrode, and thereby he called them as negatrons because they have negative charge. So this name of negatron was changed to electron by a scientist called as Stokes. Okay, so if you observe here, when I place two plates, the electron is deflecting towards the positive electrode and hitting the zinc sulfide screen. So they also produce heat energy when they collide with matter, and this cathode rays, they possess kinetic energy which is converted to heat energy when stopped by matter. That is when you get heat energy, isn't it? Even when I am heating up a substance, it will produce the heat energy. There is heat energy because of the kinetic energy, and they will affect the photographic plate. That is why they are lighting up the zinc sulfide screen. And these cathode rays can also penetrate the thin foil of solid materials. So this property is also important. Alright guys, we'll come back to this when we are reading the Rutherford model, but we'll come back to it. Now, cathode rays can also ionize the gases through which they pass, and the nature of cathode rays is independent of whatever cathode is being used and whatever gas is present inside the cathode tube. Alright, generally an inert gas is present in the cathode ray tube, and a zinc sulfide screen is present, and it can be deflected by electric fields. So these are the properties of the cathode rays. So now, when we look at the cathode ray tube, this is what was observed. So there is a cathode, there is an anode, and as it emerges from the cathode, and if I place two electric plates, it will deflect towards the positive plate and hit the fluorescent screen. So this would be the, if there is an electric field. If there is no field, it will straightly hit the B. So based on what is the field created, okay, or if I give magnetic field, it will deflect towards the A. So based on the electric magnetic fields or no fields, there was deflection of these rays. So thereby it was concluded that these are negatively charged when because they are moving towards the positive electrode and hitting the fluorescent scene, and thereby it is called as electron. So this electron measurement, they measure the charge over mass by studying how they are deflecting in this electric and magnetic fields. They move when electric field is given, they will move towards the positive, and magnetic field is given, they will rotate perpendicular, isn't it? Because it is electric. So they will change the direction. So J.G. Thomson determined the value of this charge over mass to be minus 1.7558 times 10 to the power of 8 coulomb per gram. Okay, so this is the charge over mass. The charge over mass is called as specific charge. So if you see a term called as specific charge, that means it is charge over mass. The term specific charge means charge over mass. So whichever gas I take or whatever electrode I take, always the charge over mass will remain the same value, minus 1.7 times 10 to the power of 8 coulomb. Now we have to determine what was the charge of the electron. So R.A. Millikan was the scientist who determined this charge. So he used something called as oil drop experiment. So what he did was he used a spray gun for oil drops, and he placed 2 chargeable plates and he passed X-rays in them. So when X-rays was passed, they give out some electrons. Okay, they give out some electrons. So which caused whatever air was present, they give out some electrons, and these electrons were carried by oil drops. So based on the density of the oil drop, based on the size of the oil drop, they will move, because the electrons are charged and they are placed between the charged plates, and the electron has negative charge which is captured by this oil drop. They will move. So based on the movement, based on the density of the oil, the size of the oil droplet, we can determine the electrical charge. So this charge was found to be minus 1.76 times 10 to the power of 8 coulomb per gram was the ratio of charge over mass. Whereas the charge was found to be, this was found by J.J. Thomson and this was found by Millikan. He found the charge to be minus 1.6022 times 10 to the power of minus 19 coulomb. So C represents coulombs. So this is the charge. So mass of the electron was found out based on the charge over mass, that is specific charge and charge, and found to be 9.10 times 10 to the power of minus 28 grams, which is negligible. So this is the charge, this is charge over mass, and this is the mass values. Alright, so you guys need to remember this. They'll ask you questions. A simple multiple choice question may appear. Next one. So that was about electron based on the cathode ray tube. The next one is discovery of proton. So Goldstein was the first person who led to the discovery of positive particles. So what he used was, he used a perforated cathode and an anode, and he used a H2 gas inside with a low pressure. Now, if there was a high charge difference, very high charge difference when it was that is potential difference when it was applied. So he observed that not only cathode rays were being produced, but there were also some other rays which were emitting out. Okay, there were other rays which were moving towards the cathode. So cathode rays will emerge from the cathode, move towards the anode, whereas anode rays, so he observed some rays which emerged from the anode and were moving through this perforated cathode and hitting this zinc sulfide screen and creating a flash. So he called them as anode rays. Okay, he called them as anode rays. So when these properties were studied by Thomson, he observed that they are positively charged particles because they are moving towards the cathode. He observed that they are positively charged and named them as positive rays. So what were the characteristics of these positive rays? Again, similar to cathodes, they traveled in straight lines and casted a shadow. Like cathode rays, they also possessed kinetic energy and they were able to rotate a pinwheel when placed in the path, and they also had heating effect. So rotation and heating says that they possess a kinetic energy. Next, they were also deflected by electric and magnetic fields, which represents that they have a charge. So what is the charge? It is positive charge. Okay. And they produce flashes in zinc sulfide screen, and they can pass through thin metal foil. They also produce ionization of gases, and also the specific charge was determined even for these rays. So they observed that the charge over mass was much lower when compared to the electrons. Okay. So this is the first difference between an electron and proton. There were a lot of difference between the charge over mass, E over M value for positive and negative, that is electrons and protons. So if it is a small value, that means there is not much of a difference between the charge and mass. That means these positive particles might possess a very high mass. That is the conclusion they arrived looking at the charge over mass. And they also observed that the charge over mass value again would not depend upon, is dependent upon the nature of gas. Based on whatever is the nature of gas, whatever is the charge over mass ratio is dependent. So this is what they had observed. So based on all these, they got E over M value as plus 9.5 times 10 to the power of 4 coulomb per gram. So because it was assumed that this is a positive charge, okay, that is a positive charge, this particle was named as proton by Rutherford. Although it was discovered by Goldstein, it was named as proton by Rutherford. The charge was determined to be plus 1.602 times 10 to the power of minus 19 coulomb, which is exactly equal to the value of electron. In proton it is positive, it is negative in case of electron. So based on charge and charge over mass, mass of proton was determined to be 1.672 times 10 to the power of negative 27 kilograms. So that was about proton, the positively charged particles. Next it is neutrons, isn't it? We are done with electrons and protons. The next one is neutrons. So in 1932, after a long time after the discovery of electrons and protons, Chadwick, right, he bombarded beryllium. Beryllium is an element which has an atomic number of 4 and a mass of 9. Okay, 9 atomic mass units. He bombarded it with alpha particles. So that means by the time the neutrons were discovered, the radioactivity of a substance were discovered by Becquerel. Becquerel was the scientist who determined the radioactivity. So they discovered alpha particles, gamma particles by then, which was used in this experiment. So they used alpha particles which has the charge of +2 and a mass of 4. So make sure you are remembering whatever charge and mass wherever you are reading it, because you might get questions in ordering, increasing order of charge or decreasing order of charge based on electron, proton and neutron. Okay, so the alpha particle has a charge of +2 and a mass of 4 atomic mass units. So when this was bombarded, okay, you got a carbon atom with 6 and the mass of this, and they got something called as neutron, which showed a mass of 1 AMU. 1 AMU means whatever is the mass similar to the proton. Okay, so he observed that whatever the radiations which were generated were not affected by electric and magnetic fields. So that means they consist of neutral particles without charge. So that is why they are called as neutrons. They also determined the mass to be 1.675 times 10 to the power of -4 grams. Whereas for protons, it is also 1.674 times 10 to the power of -24 grams. The E by M value for a neutron is 0 because the charge is 0. So this is the summary of whatever we have read so far. Make sure you take a screenshot of it, whatever is the scientist, the charge. So electron is always negative charge, discovered by J.J. Thomson. This is the charge, this is the mass, this is the specific charge. Specific charge means charge over mass. So it is considered as -1 unit. Proton is discovered as Goldstein, isn't it? So it is, the charge is again plus 1.6 times 10 to the power of 19, and this is the mass, and this is the specific charge. Neutron was discovered by James Chadwick. The charge is 0. Again, the mass is 1.675, similar to the proton. So that means charge of proton and electron is similar, mass of proton and neutron is similar. Alright. So there are other subatomic particles also which are present, which was slowly discovered. Positron, for example, which was discovered by Dirac and Anderson. They are very, very unstable and they produce gamma rays immediately on combining with electrons. They are a positive electrons. So there are neutrinos and antineutrinos, which was discovered by Fermi, okay, which can spin based on the spinning. There are meson particles which are eta, pions, kaons. They have intermediate mass. There are antiprotons, there are also mu particles. So there are different kind of these particles which are also present inside the atoms, which are very, very unstable. So the most stable particles inside these are electron, proton and neutron. So that is why these are the subatomic particles which we study. So this was the first theory which was put by Dalton, isn't it? That atom is indivisible. So it was proved wrong once on the discovery of electrons, protons and neutrons. Now, whenever we look at a representation of an atom, so this is how it will be represented. I will write an element name. I will write a symbol here and a symbol here. You'll see the numbers, isn't it? So here on the left bottom side, whatever we write is representing the atomic number. On the top right hand side, we determine mass number. Mass number is represented by A. Atomic number is represented by Z. I know it's confusing, isn't it? Atomic number A, it would have been simpler, but yeah, it is confusing. So Z represents atomic number, A represents mass number. Mass number means, okay, the number of protons plus number of neutrons. Number of protons plus number of neutrons is called as mass number. So that means because electrons possess a negligible mass, we always give whole number for this. Atomic number, which is represented by Z, okay. So the number of, for a neutral, if we are taking, okay, for a neutral, we are taking number of protons will determine the number of electrons, isn't it? So atomic number is represented by number of protons, okay. So that means we are giving the nuclear charge. So if we have a nucleus inside, what is the charge of the nucleus is what we will represent. Why not electrons, you may ask? Because electrons are involved in a reaction. So whenever we take a reaction, the electrons are constantly changed. There might be formation of ions, there might be exchange. So because of that reason, we take atomic number is represented by number of protons, not number of electrons. Okay, the number of protons will always remain the same. Now, if I am taking a neutral atom, that means zero charge, the number of protons should be equal to number of electrons. Clear? Now, if it is a charged atom, then it is going to be different. So now let's look at that. Okay. So if I say this is the formula, 17Cl35, this is how it is represented. That means 35 is the mass number. 35 is the mass number. Mass number is represented by A. Now 17 represents atomic number, which is represented by Z. So Z means it is equal to the number of protons. So that is why number of protons is given as 17. Okay. Now this is neutral. There is no charge on chlorine, isn't it? So that is why number of protons is equal to number of electrons, and electrons will also be 17. So 35 is the mass number, 17 is the atomic number. So number of protons is also 17, number of electrons is also 17. So now what about number of neutrons? What is mass number? Protons plus neutrons, isn't it? So that means 35 minus 17 should give me number of neutrons, which will give you 18. So this is how we represent. We will find out what is the number of neutrons, electrons and protons. So always number of neutrons is determined by mass number minus atomic number, which will give you the number of neutrons. Okay. So suppose this is the question. Now I told you that the number of protons, before we go into this question, the number of protons, if it is neutral, then proton is equal to number of electron if it is a neutral. If it is charged, so that means sodium if I take, okay, the number of protons is 11. So that means proton equal to 11, and if it is neutral, electron will also be 11. Now if it is charged, if sodium I am writing as Na plus. So that means what does plus represent? I am taken off one electron, isn't it? So the number of electrons will become 10 electrons. Okay. Similarly, if I write F minus, okay, for a neutral atom, there is 9 protons in fluorine. So that means for a neutral, there should be 9 electrons. So if F minus, minus represents it has taken 1 electron. So there should be 10 electrons in F minus. So based on the charge, positive or negative, we will represent the number of electrons of protons. Now let's look at this question. If number of protons in X minus 2 is 16, what will be the number of electrons in X plus 2? Okay, see here, the number of protons. So whenever I said Na plus F minus, I said, right? So number of electrons were changing. So initially it was 11 and then it became 10. Here initially there were 9 electrons and then it became 10. But number of protons will always remain as the same. The number of protons will not change. The number of protons also change, then automatically the charge will change, isn't it? It was neutral because the protons was equal to number of electrons. Okay. So now in this question, number of protons was 16 for X minus 2. So no matter if it is X minus 2 or X plus 2, X times million minus 2, anything, the number of protons is going to remain constant. So that means for a neutral atom, of X, the number of protons will still be 16. So if it is neutral, the number of electrons should also be 16. So if I write X2 plus, that means I am giving away 2 electrons. It would be 14 electrons. So the answer is 1. Okay. So no matter what is the charge, the number of protons will remain the same. Okay. So the next one is atomic weight. So you guys, we have taught a lot about atomic weights, isn't it, in our previous class? So we are going to read about isotopes, isobars, different kinds of things. So before I go into that, I just wanted to give you this formula. You might get a question. It comes in rarely, but if it comes, okay. If there are 3 isotopes, okay, and that is Y1, Y2, Y3 are the isotopes, and their weights are given to be W1, W2, W3. But how much percentage they exist is different, isn't it? That is, the percentage of isotopes which exist, they might be different in the nature. They might be only 0.1% or 0.2%. So, suppose for carbon 12 is there, carbon 13 is there. There are different kinds of isotopes, isn't it? So these percentage might differ. So average atomic weight is given for such elements where there are different kinds of isotopes based on the percentage of each isotope. So weight of the isotope times percentage plus whatever isotopes are present divided by all the percentages will give you the average weight. So W1 X1, W2 X2, W3 X3 divided by X1 X2 X3 will give you the value of average atomic weight. Alright. Now isotopes. Okay. Isotopes. What are isotopes? It was actually given by Soddy. The name was given by Soddy. Whenever there is same atomic number and different mass number for an element, it is called as isotope. So it says same atomic number and different mass number. What does it mean? Atomic number is same means proton is same. So in mass number, there should be a difference in number of neutrons, isn't it? So I have 2 isotopes. We have 17Cl35, 17Cl37. See here, there is a difference of 2 neutrons. There were 18 neutrons in chlorine 35, whereas there are 20 neutrons in chlorine 37. So because the number of protons are same, they will have same chemical property. The protons will determine, that is the effective nuclear charge determines the chemical properties. So they will have same chemical property but different physical properties. Also, they will not have the same specific charge over mass ratio, because the mass will vary based on the number of neutrons. So same atomic number, different mass number, that is difference in neutrons, is called as isotopes. The next one is isobars. Okay, it was given by AST. So whenever an element has same mass number but different atomic number, then it is called as isobars. Whenever they have same mass number but different atomic number. So this will happen, okay, when they have a different number of everything. So look at these two elements, 1H3, 2H3. The mass number is same. But again, if you see, the protons are different, isn't it? So combination would be different. So if you look here, the proton is 1. So automatically electron is 1. So 3 minus 1, neutron is 2. So the total number is again 3. If you look here, the number of proton is 2 because atomic number is 2 and electron will be 2, but neutron will be 1, 3 minus 2. So the sum is equal, but the number of electrons or protons or neutrons will not remain the same for any of the elements. Okay, so they are different, but the sum is the same. So these elements are called as isobars. Okay, isobars are which have same mass number but different atomic number. So they do not have same chemical or physical property because they do not have any equal number of protons or neutrons, and they will also have not same charge over mass ratio also. Next one is isodiaphers. Isodiaphers is something where different element will have same difference of number of neutrons and protons. That is, the difference in neutrons and protons should be the same. So if you look at boron and carbon-13 isotope, okay, the number of protons is 5 because atomic number is 5. Now 11 minus 5, number of neutrons is 6, electron is 5. Here if you see, atomic number is 6, that means proton is 6, neutron is 7 because 13 minus 6 and electron is 6. So if you look at neutron minus proton, you get 1 and 1. So when they have similar neutrons and proton difference, such substances are called as isodiaphers. The next one is isotones or isoneutronic species. Isotones are isoneutronic species. So these are the elements. They are different elements, but they will have same number of neutrons. In isotope, it was different number of neutrons. Here, the same number of neutrons. Here, atomic number or mass number will not be the same. Just the neutron number will be the same. So for example, if we look here, these two are isotones. So the proton is 1 here, number of protons is 2. So the electron will be 1 and electron will be 2. Whereas neutron, if you see 3 minus 1, 2, 4 minus 2, 2. The neutrons is equal because they are called as isotones. So this might happen when based on the mass numbers of it. So in all these things, you will have similar chemical property only in case of isotopes, not in any of the others, because only that depends upon the number of protons. Only there the number of protons are same. So because of that reason, the electrons also will be same, and thereby the chemical property also will be related. Is it clear? We have isodiaphers, we have isobars, which differ in the, which have same mass number. We have isodiaphers and isotopes. The next one is isostars. Isostars depends upon the number of atoms and electrons. So they have same number of atoms and same number of electrons. They will be called as isostars. So if you look at these two examples, CO2 and N2O, what are the atoms present? C and 2 oxygens. So the number of atom is 3, number of atom is 3. Now only if this is equal, it is not isostar. Also the electrons should be equal. So how do I determine the number of electrons? In carbon there are 6 electrons, and in oxygen there is 8 electrons because atomic number is 8. So 8 times 2. So they have 22 electrons. Similarly, nitrogen has 7. So 7 times 2 plus 8 will give 22 electrons. So when they have same number of electrons and same number of atoms is present, Such elements are called as isostars. So this example has come in a lot of papers. Which of the following is isosteric species? So make sure you understand this. Next one is isoelectronic species. Even this is very important. There have been questions, lot of questions in this. Okay. So isoelectronic species mean, okay, whenever the number of electrons is same. Okay. When will the number of electrons be same? When it is a charged species, it might happen, or for a neutral species also it might happen. So chlorine minus. Chlorine has the atomic number of 17. So chlorine minus means 18 electrons. Argon's atomic number is 18. So it has neutrally it has 18 electrons. So a chlorine minus and an argon will be isoelectronic species. Even H2O and NH3, if we count the number of electrons present, it is equal. It is not isostar because in this the number of atoms is 3 and in this it is 4. So that is why it is not isostar, it is only isoelectronic species. Now, if you see BF3 and SO2, again they have same number of electrons, but the number of atoms are different. Here there is 4, here there is 3. So they are only isoelectronic, they are not isostars. Okay, isoelectronic means the number of electrons should be the same. Okay, so we discussed at different kinds of species, how the discovery of electron happened, how proton was discovered, what are the different, what is mass number, what is atomic number, how do we calculate protons, neutrons, electrons, and all that. Now, we are looking at structure of an atom. So, electrons were discovered by JEE Thomson, isn't it? So, he gave a model for atom. Okay. So, he gave a model that the electrons will be dispersed like this, okay, similar to a plum or watermelon inside a big positively charged spread. So electrons will be just dispersed throughout. So this is called as plum pudding model. So this model is called as plum pudding model. Okay. Now the electrons which are present, the plums are made up of negative charge and the dispersed is called as positive charge. So there is one drawback which doesn't state why the mass of atoms is considered to be evenly spread over atom, because the mass is not evenly spread and it is a static model. It doesn't represent how the electrons are moving. So that is why this model was discarded. Okay. The next model was put forth by Rutherford, who gave the positively charged particles. He gave the name called as protons. So what he did was, he did something called as alpha scattering experiment. So what he did was, he took a alpha particle emitter and he passed through a very small slit into a gold foil. So remember that the protons, electrons, all these, they will pass through the metal foil. Right or wrong? Do you remember that they have the property of passing through the metal foil? All these, they have the property of passing through the metal foil. So when he started passing them through a slit, what he observed was that most of the particles were passing through, okay, but there were very small particles which were getting deflected back. So it was detected in the screen, which is again zinc sulfide. So he detected them in this circular screen and he observed that whenever they were passing through the center, the particles were getting deflected. So this alpha particles which passed straight without deflection, okay, they might be electrons, and very few alpha particles were deflected. Alpha particle is positively charged, isn't it? So positively charged means it can be a positively charged nucleus might be present at the center, which is deflecting back the alpha particles. So that was the Rutherford's model. So he proposed that atom contains a dense and positively charged region at its center called as nucleus. Okay, he gave the term as nucleus. Now all the positive charge of an atom and most of its mass was contained in nucleus. And he also said that the rest of atom must be an empty space which contains much smaller and negatively charged electrons, because the particles were passing through without any deflection, and he observed that the nucleus is going to be inside. the total negative charge of electrons should be equal to total positively charged so that the atom is electrically neutral. So this was the model proposed by Rutherford, that there is a central nucleus and most of the positive charge is contained inside the nucleus and also the mass, and electrons are dispersed in the empty space. Okay. So based on this experiments, he proposed the model. So these were the postulates he put through. So that is, it has a positively charged nucleus where the protons are present, and that the volume of nucleus is very, very small because only very small fraction was actually deflected, isn't it? So because of that, he said that the volume of nucleus is about 10 to the power of fifth of, that is, the atom would be 10 to the power of fifth to that of nucleus. So this is what he put forth. Okay, so what we saw in the atomic radius in our first slide, that the radius of atom is 10 to the power of fifth to that of radius of the nucleus. Okay, and the radius of the nucleus is also proportional to the number of neutrons which is present in it. Okay, so if you have to create, so the radius would be proportional to the 1/3 cubic root, okay, cube root of the number of neutrons, that is the mass number present inside. So we can also give the radius of the nuclei using this formula. Next one, he also said that there was a lot of empty space around the nucleus, which is extranuclear part, in which the electrons will be present. So the electrons which will be present is about, so the volume of the atom is about 10 to the power of 15 times to the volume of nucleus. And he also proposed that the electrons will be revolving around this nucleus in a closed orbit in a very high speed. So he compared it to a solar system. That is how the orbits will be, and the electrons will be rotating around. So that is what he had proposed. Next, he also proposed that this is similar to a solar system. So what were the drawbacks? He said that the electrons are in of the atom. So because according to Maxwell, he said that if the electrons are constantly rotating, they will lose their energy in the form of electromagnetic radiations, because electrons can give electromagnetic radiations. So they should have released their energy completely, moved closer and closer, and ultimately fall into the nucleus. So they cannot have a fixed orbit was the, so if you could not explain how they are stable if there are fixed orbits. Okay, now if electrons lose energy continuously, okay, whatever spectrum which is observed should be continuous, but it has generally a discontinuous spectrum. So that means the loss of energy by an electron is not continuous in an atom. We will be looking at this observed spectrum in our coming slides. Alright, so if an electron, when it is giving away the energy, we can observe, because it is giving electromagnetic radiation, we will be able to observe the spectrum of it, how it is giving off its energy. So when we observed that spectrum, it was not continuous, it is discontinuous. So that means they cannot be revolving around continuously. They cannot lose their energy continuously. So these are the two major drawbacks of a Rutherford model. Okay, so let's look at a question. Which of the following sets of ions represents a collection of isoelectronic species? So what are isoelectronic species? Whichever have same electrons. So now let's look at the option A. So it is lithium, sodium, magnesium and calcium. So okay, first thing, lithium and sodium, how are they closer together? Lithium is in the top and sodium is in the next period, isn't it? So there is no way that A can be the answer. Okay, no way A can be the answer, isn't it? They have to be in one single period or at least very close together, isn't it? Only then it is possible. So now let's look at this option. Okay, potassium, chlorine, calcium. This can be answered. So potassium is, what is the value? Potassium has 19 and chlorine has 17 as the atomic number, calcium has 20, cadmium has 21. This is the possible answer, isn't it? So it is K plus. That means the number of electrons is 18 electrons. So this is the atomic numbers of each. So potassium it is this, chlorine it is this, calcium it is this, and cadmium it is this. So number of electrons, K plus means it is 18. Chlorine minus means 18 electrons. Calcium 2 plus means 18 electrons. Sc 3 plus means 18 electrons. So that means answer is B. So whenever you are looking at this answer, you have to see if they are of not same period, if they are of same period or they are just one element away. So only that answer can be your answer. So when you are doing this, don't do a very long, use your brain and try to do it. Alright guys. Next one. There are two things given. Atomic number and mass number of an element is given, and the number of electrons and protons in the M2 plus ion is respectively. They have given atomic number and mass number. We have to find out what is the electrons, protons and neutrons. So atomic number is 25. So that means number of protons will be 25. Mass number is 52. So that means mass number minus atomic number will give you the number of neutrons. So 25, 27. That represents the protons and neutrons. Now what about electrons? It says M2 plus. If it was neutral, there would have been 25 electrons. So because it is 2 plus, that means 2 electrons are removed. So 25 minus 2, there will be 23 electrons. So the answer is 4. This would be the answer in this question. So that was about all the models, atomic model, Rutherford, discovery of electron and proton. So the next one we are going to look at is electromagnetic radiation. We are dwelling it much more than what we have learned in your 9th standard. Okay, so we are going to be looking at electromagnetic radiation and Bohr's atomic model, and we are going to look at what are the spectrums which are available. So there is a lot which you are going to study in the next coming part. So the first one of it is electromagnetic radiation. So if an energy is transmitted from one body to another in the form of waves, and these waves, if they travel with the speed of light is 3 times 10 to the power of 8. So then those waves are called as electromagnetic waves or radiant energy. This radiant energy does not need any medium of propagation. So all the air, water, solid, any heat can be transmitted through this radiation. Okay, so this is in the form of waves and they will travel at the speed of light. So this is the composition of the electromagnetic radiation. Okay, we have cosmic rays. So this is the angstrom. Here it is 10 to the power of 12 and 10 to the power of minus 4. So that means what is the wavelength? So this here represents the wavelength of it. So we will be going to talk about these terms called as wavelength, amplitude, frequency, which I'll be discussing in further. So here this represents the wavelength. So this wavelength is 10 to the power of minus 4 and this wavelength represents 10 to the power of 14. So if it is more wavelength, that means it has less frequency. Okay, that means less harmful, less energy. So if you look at these things, X-rays, they have very high energy, isn't it? So that is why they have very short wavelengths. They are very high energy. These are very low energy waves. Okay. So in the center we have visible. VIBGR color is present in the center between the 3800 and 7600 angstroms. So next to it we have ultraviolet and infrared. Infrared has less energy when compared to visible. Ultraviolet has more energy. That's why ultraviolet is very damaging to the skin, isn't it? And then we have X-rays through which we can see bones. We have alpha rays, we have cosmic rays, also gamma rays here, and we have microwave rays and radio waves. So radio waves is, that's why, because they travel a very long distance, it has a very long wavelength. That is why we can use it for FM and all. Okay. So this wave, when I said it has wave nature, the wave has following 6 characteristics which we are going to say. So this is what represents a wave. Okay. This wave always will have a height called A, which is called as, okay, crest, and the down going part is called as trough. Upper part is called as crest, down point is called as trough. Okay. So the difference between two crests will give you lambda, which is called as wavelength. Okay. So when I said wavelength here, that means for between two crests of a cosmic wave, it should be 10 to the power of -4 angstroms. Okay. Or between two troughs, two lower points or two upper points. So it is the distance between two nearest crests or tau. It can be given in angstroms, picometer, nanometer or centimeter. That is the first one. The next one is frequency, which is represented by nu. Okay. This represents how many waves can pass through a point in a one single second. So if this is 1 second, in this there is two waves which is passing through, isn't it? So it is given in terms of hertz, or the value is per second, hertz or per second. So the time period generally which we take is 1 second. Okay. Next one is velocity. Velocity means how much distance is covered in 1 second. Frequency is how many waves. Velocity is how much distance is covered. So that is why velocity is given by the formula lambda by t. By t, 1 over t means frequency. So velocity is equal to lambda times mu. This is the formula. Velocity equals lambda times mu, or mu, that is frequency, equals to c over lambda. So always if more frequency, that means less lambda, less wavelength. Okay. Next, wave number. Wave number is just a reciprocal of wavelength. It is not frequency. It is just a reciprocal of wavelength. Okay. So that is wave number, which is represented by nu bar. So how it is written? Nu bar. Okay. This is not V. This curve should be there. This what represents nu. V should be written like this, isn't it? This is what represents nu. Nu bar is called as wave number. Next is amplitude. Amplitude is what is the height of this crest. That is this A. A is what represents the amplitude. What is the height of the crest? It is given by, so mu is c over lambda, and wave bar can also be written as c mu bar. Okay. So this is about electromagnetic radiation. So we looked at wavelength, amplitude, frequency, velocity. What are the formulas, isn't it? So there is a theory called as Plancks quantum theory, which denotes electromagnetic radiation. Okay. He proposed that according to this quantum theory, they said that the electromagnetic radiation which is given off, the energy which is given off, okay, it is not given continuously in the form of waves, not just waves, but they will have packets of energy, which is called as quantum. That means it is not continuously in waves, but they will have small packets of energy which is there, which is given as quantum. This packet of energy is called as photon. That means the light, the energy contains photons. We have photons. So this energy of each quantum depends upon the frequency. Frequency represents number of waves, isn't it? So this energy represents the waves. So that is why E is proportional to mu. That is frequency. E equals h mu. Mu is c over lambda. That is velocity over wavelength. So that is why we can write as E equal to h mu, or E equals hc over lambda. H here is called as Planck's constant, where Planck's constant is 6.626 10 to the power of -37 kilojoules per second, or joules per second. Okay. Joules is generally taken when velocity is given in meters and lambda is taken also in meters. We will take this value of 6.626 minus 10 to the power of -34 joule seconds. Okay. This is the value of Planck's constant. This formula here is very, very important. There are a lot of questions asked in this. Okay. So that is Planck's quantum theory. So the next one, what he said, that the energy are given in packets, and these packets will contain the energy E equal to h mu. Okay. So now if n is an integer where it is multiplied, that is there are a lot of quantums, I can give it as E n h mu. Also, if I have to incorporate wave number, okay, I can write it as hc times wave number. Wave number represents 1 over lambda. So energy can also be represented as, let's see, wave number. So the next theory which we are going to come across is called as Bohr's atomic model. Okay, Bohr's atomic theory. Okay, in this there are some important formulas which we are going to study. Okay, this is a theory which has to be studied in at length. Okay, there are different postulates which are given here, which represents based on this quantum theory and mechanical model. So you have to make sure you understand this really carefully. So we will be reading this in our next part. So till now, what did we cover? We covered what is the discovery of electron, discovery of proton, neutron, what is cathode ray tube experiment, gold foil experiment, silicon oil drop experiment, what is the charge of electron, charge of proton, charge of electron, specific charge, and what is electromagnetic radiation, what are isoelectronic species, isotopes, how to determine the, so make sure you are writing down all the formulas here and you are memorizing it, because we are going to be doing questions in our part 2 and part 3. So I'll be discussing the questions all together at one space so that it is easier. Make a formula chart and start discussing it all together. Okay, so this is theory chapter, so you have to make sure you are going through all the formulas. Okay guys, so see you tomorrow. And I'll be teaching you Bohr's atomic model, de Broglie's wavelength, further into the structure of atom. Alright guys.